Hey Calculus, we are ready to tackle 6.4 and I feel like it'd probably be best if I just shared the answer key. If you would like, you could try this on your own. What do you think the following are equivalent to? And you might want to hit pause because I'm going to quickly go over to this part and share the answers with you. So the main premise with this is if your starting integral, your starting and your ending are the same, I like how he phrases it this way as I think it's helpful. But basically there's no area under the curve. So it makes perfect sense if there's no area under the curve where you start and end at the same point that it equals 0. I do like how he explains it where capital F is the antiderivative of lowercase f. So it makes sense that it's f of the upper value, f of a, minus f of a, the lower value, and anything minus itself will give you 0. So I like his explanation there. So as I scroll down, what he points out is if you think about this as a Riemann sum, if some c values in between a and b, then what you can do is you can add two separate integrals together to have something that's equivalent. So I've also seen students that will put like a diagonal line. Right now I can't really draw a diagonal line on this page to show that the ending at one point is the same as the starting in the other. So just think about the Riemann area, the area under the curve. I think that makes perfect sense. If not, please bring some questions to class. So as I look at the next one, I like how he breaks it down as two different things. So basically what it boils down to is if you know the area under the curve from a to b of f of x dx is equal to some k value, well, if you switch your endpoints around, so from b to a, it's the same area, but it's a negative value. Just how velocity gives you direction, same thing with the antiderivative. The definite integral would give you a negative value as well. So how is that useful is you can think of it this way as well. So let me kind of put a box around that. Is if you think of it with the antiderivative as he showed earlier, that the integral from a to b of f of x dx is the same as capital F of b minus capital F of a. Check the endpoints. Well, if you think of it, if you switch those endpoints, then it makes perfect sense. That's capital F of a minus capital F of b. Well, if you factor out a negative out of that, then you can change the signs. In other words, you can flip it around, and you get negative. They're negatives of each other. I feel like I should probably work that out, but I'm going to leave it as is. Which brings me to number 4, which is pretty much the same thing as number 3, is if at any point you need to switch these two values around, you factor out a negative. Let's see. This is a constant rule that if you have a k inside of an integral or a definite integral, you can just move that k in front. That's accepted to be true. We could actually prove it if anybody's interested. And in a similar manner, if we have two functions, we can do each definite integral separately. And it's a plus or minus situation. Which brings me to number 7. What you could do if you have an even function. Okay, this only works for an even function. So there's a lot of different examples of even functions, but the easiest case for all of them is if we have symmetric with the y-axis. So just a reminder from pre-calc, even functions are symmetric with the y-axis. What you need to double check then, so again it has to be even, is we have the same area to the left as we do to the right. So that's why it's important that a and negative a, that a is the same value. And I like the picture that he drew here because the picture shows that the area under the curve to the right is equal to the area under the curve to the left. So the premise is that you can just do half of the integral. So instead of going from negative a to a, you can go from 0 to a and then double that area. And I hope that makes perfect sense when you look at the picture. You can also do it this way, although I would not necessarily advise you doing it that way. And then what about an odd function? Well, an odd function, because the integral measures positives and negatives, you can just do the same problem. And as a reminder, odd functions are symmetric with the origin. So being below the x-axis means it's a negative area, and being above the x-axis is a positive. So they will cancel each other out as long as the a is negative a to positive a. Okay, that has to be the same distance. So these are all the rules. If you need to, go back, rewrite them, hit pause, do what you need to before moving on. So now we can answer a few questions from this. And all we need to know is these two things. So as I look at this problem, somehow I need to get it in terms of these two functions, these two known facts. So what I might do is rewrite the problem and just switch the bounds around. But if we go back to the previous page, the rule for switching the bounds around is that you have to negate. So by switching these two, we have to negate, which then we could say, hey, this answer, the integral from 0 to 3 of f of x dx is equal to 6, and just bring that negative straight down with it, and that is your answer. So as I look at the next one, it might make sense to rewrite it as the integral from 0 to 3 of f of x dx plus the integral from 3 to 7 of f of x dx. And let me get a highlighter out just to kind of prove my thought process is this value and this value are the same. And if you think of it, if I were to draw f of x somehow, if I knew the curve, this is a terrible curve, by the way, from 0 to 3, because definitely from 3 to negative 8, I did not make it a negative area. But all I'm doing is I'm splitting those answers up. So I should definitely get rid of that because that does not match anything. But what it boils down to, so this follows straight from our rules, is from 0 to 3 is 6, and from 3 to 7 is negative 8. And 6 plus negative 8 gives me an area of negative 2. All right, I'm going to have to go up and down to get all this. Although this next one, I actually don't need any clues, because if the lower bound and the upper bound are the same, that answer is 0, no work to be done. Okay. You'll notice that they try some sneaky things here as well, because this next one, let's change colors again, is there's a sneaky 3 inside of there. So what I'm going to do is move the 3 in front as well, and I bet you noticed that we need to switch those around. Well, to switch them, we negate our answer. Of x dx. So hopefully I've explained this good enough. And again, back in the directions, from 3 to 7 is equal to negative 8. So we're looking at negative 3 times negative 8 to give me positive 24. This next one's a little tricky, okay? And I'm going to try to explain this as best as I can. So we have the integral from 3 to 7 of the function 2 dx plus, I'm going to do two things here. I guess I'm technically doing three things now. I'm going to move this 3 in front. The integral is still the same of f of x dx. But let's explain exactly what's going on. That doesn't look like a 3 right there. Let me fix that. There we go. Well, let's first do this piece, because 3 to 7 of f of x dx is equal to negative 8. But let me explain with a picture what this actually means. Now remember, this just means that we have a horizontal line at y equals 2. Y equals 2. And we want to go from x equals 3 to 4, 5, 6, 7. So from 3 to 7, and we have a little picture right here that is the area is 8. It's 4 times 2. So that answer is 8. And if that didn't make sense, we could do the problem the same way we've done before, where the antiderivative of 2 is 2x. Because think about the derivative of 2x is 2. From 3 to 7, and if you did the math that way, you would say, okay, well, it's 2 times 7 minus 2 times 3. And what do we get? 14 minus 6. Hey, that's 8. So good, we did it right. So what's our final answer? Let's go back to blue. Is 8 minus 24 to get an answer of negative 16. Okay, so hopefully I said something there that made perfect sense. Okay, the next one. They give you an extra clue in here. We have an even function. Now remember, I just remember that even is symmetric with the y-axis. That's how I remember how to do these. Because I'm thinking if it's symmetric with the y-axis, then, and I notice that my bounds are the same but opposite, then this answer is equal to doubling the integral from 0 to 3 of f of x dx. And I use the same picture that the author has in the notes. So as I go back to the top, the integral from 0 to 3 had an area of 6. So what that means is we have to double 6, and our answer is 12. And then what if we switch things around and we had an odd function? Again, I just think about odd is symmetric with the origin. So if it's symmetric with the origin, we're going to have stuff below the x-axis and stuff above. And remember, below the x-axis is negative and above is positive. And it also works the other way as well. Because what if we had like negative here symmetric with the origin? It would be positive over here. So let me cross that off. They still cancel each other out as long as these bounds are the same. So this answer is merely 0. They will cancel out. And please, please, please write down any questions you have. Let me know what's confusing, and we can talk about it in class. I think this might be a good place to stop because I still have a few more things to discuss, and I'll save that for a second video.